Hey, Gearheads, Jay Leno here, and today we're taking a trip down memory lane to explore the fascinating evolution of cars. From the early days of steam to the roar of the internal combustion engine, it's been quite a ride. Imagine a time before cars, when horses and carriages ruled the roads. One of the earliest attempts at a self-propelled vehicle was the steam-powered Cugnot Fardier in 1771. This three-wheeled behemoth was designed to haul artillery but proved to be impractical for everyday use. However, it paved the way for further innovation. Fast forward to the late 19th century, and inventors like Carl Benz and Gottlieb Daimler revolutionized transportation with their gasoline-powered internal combustion engines. Henry Ford's Model T, with its mass production techniques, made cars more affordable for the average person. The development of the electric starter in 1912 eliminated the need for the cumbersome hand crank, making cars even more accessible. From the sleek designs of the 1930s to the muscle cars of the 1960s, each era brought its own unique automotive flavor. Now let's pop the hood and take a closer look at the heart of most cars on the road today, the internal combustion engine. This ingenious piece of engineering might seem complicated, but it's actually based on a simple four-stroke cycle intake: compression, combustion, and exhaust. Think of it like a well-choreographed dance between air, fuel, and a spark. It all starts with the intake stroke. The piston moves down the cylinder, creating a vacuum that sucks in a mixture of air and fuel through the intake valve. Next comes the compression stroke, where the piston moves back up, squeezing that air-fuel mixture into a tight space. This is where the spark plug comes in, igniting the compressed mixture and causing a controlled explosion that forces the piston back down with considerable force. This downward force is what ultimately powers the car. The crankshaft converts the piston's up and down motion into rotational force, which is then transferred to the wheels through a series of gears and axles. It's a symphony of precisely timed movements, all working in harmony to transform fuel into motion. Now, let's talk shop for a minute. Understanding a few key engine terms can make all the difference when you're discussing cars. First up, we have the piston, a cylindrical component that moves up and down inside the cylinder like a runner in a race. The cylinder is the piston's racetrack, providing the space for it to move. Connecting the piston to the crankshaft is the connecting rod, which acts like a leg, converting the piston's linear motion into rotational motion. Then there's the spark plug, a small but mighty component that ignites the air-fuel mixture in the combustion chamber, creating the explosion that powers the engine. And of course, we can't forget about the valves, which act like gatekeepers, controlling the flow of air and fuel into the cylinder and the exhaust gases out. Understanding these basic engine terms will give you a solid foundation for discussing the intricacies of internal combustion engines. Section 4. The Electric Revolution, a new era of automobiles. While the internal combustion engine has been the dominant force in the automotive world for over a century, a new contender has emerged: the electric vehicle, or EV. Instead of relying on gasoline or diesel, EVs draw power from electricity stored in batteries, offering a cleaner and more efficient alternative to traditional cars. One of the most significant advantages of EVs is their zero tailpipe emissions. Unlike their gas-guzzling counterparts, EVs don't produce any harmful pollutants as they drive, making them a much greener option. But the benefits of EVs don't stop there. They're also incredibly efficient, converting a much higher percentage of energy into motion compared to internal combustion engines. This translates to significant cost savings over time, as you'll be spending less on fuel and more time enjoying the open road. Another advantage of EVs is their low maintenance requirements. With fewer moving parts than internal combustion engines, EVs require less frequent and less costly maintenance. However, EVs do come with their own set of challenges, like the availability of charging infrastructure. While range has significantly improved in recent years, it's still something to consider, especially for those who frequently drive long distances. Section 5. The road ahead, a future driven by innovation. As we cruise into the future, it's clear that the automotive landscape is undergoing a major transformation. The internal combustion engine, while still prevalent, is facing stiff competition from electric vehicles which offer a cleaner, more efficient, and increasingly viable alternative. The development of autonomous driving technology is also set to revolutionize transportation, promising a future where cars can drive themselves. From the early days of steam-powered carriages to the sleek electric vehicles of today, the evolution of cars has been a testament to human ingenuity and our relentless pursuit of progress. As technology continues to advance, we can expect even more exciting developments in the automotive world, with cars becoming smarter, safer, and more sustainable. Don't forget to like and subscribe to my channel for more automotive adventures, and until next time, keep those engines revving.